Sustainability Symposium, and it just happens to be on Earth Day, which is April 22nd today, which sometimes at the University of Scranton is a real challenge for us to get our events to land on Earth Day. I think this is the first time in at least 12 years that we're able to have a significant event that happened actually on April 22nd. So I know in the Office of Sustainability we're really excited about today to be able to have our fair this afternoon and then also our Sustainability Symposium this evening. So I just want to use this opportunity as a chance to thank everybody for coming. And the first order of business, we're going to take a quick photo up here, but I thought it'd be a good opportunity to quiet us down a little bit. But I'm also looking for Elise Gustave, because she's going to be my assistant this evening, because there's a program. It's a nonprofit portion of Procter & Gamble, which worldwide they send millions and millions of little packets of a chemical out to countries where water is sometimes this dirty. And the difference between life and death in these countries could be clean water. And it's a very wonderful program that they have. And they did give us some demonstration stuff for us to do this evening. So Elise is going to be magically turning this into clean drinking water. And at the end of the evening, I will ask somebody to drink it, so be ready, okay? So I'm going to hand this to Elise. And within about 20 minutes, this will be clean drinking water. So she's going to cut the package open, pour it in, stir it for 5 minutes, and then you let it settle, and it comes out to be clean drinking water. So we're going to take our quick photo. After the photo, we'll begin our program. Thank you. An order of business, one is to silence your cell phones if they happen to be on, so that we don't distract our panelists that are here and our presenters. And the other thing is, if you are here for credit or you're required to be here because of a class that you have, we do have the swipe card device over here, and you can swipe there after the event is over if you'd like, if you need to do that. So that's available. At this time, I'd like to introduce Jack McKenna. He's a senior student at the University of Scranton, and he volunteered to be our Master of Ceremonies this evening. So welcome, Jack McKenna, and start our program.
Thank you, Mr. Murphy. I'd like to thank you all for coming. I will now introduce Dr. Patricia Harrington.
Good evening, everyone. It's a pleasure to be here. Today is Earth Day, and more than 1 billion people in almost 200 countries, from Albania to Zimbabwe, are taking action today to protect the planet. They organize demonstrations, they contact their elected officials, they plant trees, they clean up their communities, they demand renewable energy, and they conserve natural resources. Earth Day is truly a day of action. Here at the University of Scranton, our week is filled with events that remind us how dedicated this community is. I want to thank Mark Murphy for his thoughtful leadership, and the students, the staff, and the faculty who work together every day to protect the planet and make it a better place for future generations. I hope that you can all participate in the events scheduled this week, from tonight's Sustainability Symposium to the 5K fun run on Saturday. There is something for everyone. Thank you so much for your support of this important work.
At this time, I'd like to introduce Professor Nicholas Truncale, who is a physics and electrical engineering, is in the physics and electrical engineering department at the university. His presentation tonight will be on water and the human condition. I'd also like to thank him for his work in putting everything together for the Spring Sustainability Symposium tonight.
So can everyone hear me? I have this lapel mic on so I can walk around the room a little bit. All right, so Jack mentioned that I'm in the physics and engineering department. So you might be thinking, why the heck am I up here talking about water? All right, if you were here in the fall, you heard me talk about this new device that we developed. This was a device myself and the physics lab equipment manager, Jim Lovin. We developed this device called the Reflective Solar Tracker. This is just a picture of it. Basically, it reflects sunlight and also rotates so it's always facing the sun. So we had the opportunity through one of the intercession travel courses to send these RSTs to locations in Africa to actually power schoolhouses and also actually just 2 schoolhouses. So one of our panelists, Caroline Earnest, this is a picture of her right here outside of St. Joseph's Secondary School in Uganda, actually assembling mobile versions of the RST. So I'm not going to so much talk about that. I'm going to leave that for Caroline during the panel discussion. But how I'm going to approach this presentation is I'm going to assume no one knows anything about water. Because to be honest, I didn't know too much about it before I made this presentation. Now you might think that's funny, right? But there's a plethora of information that you can find about the status of water in the world. So the first couple things I'm going to go through are just how people have access to water around the world, and then a little bit about our water use as Americans, okay? So, there's the world. Everyone knows that there. So if you look at all of what I'm going to call the developed countries, so this would include the United States, Canada, Europe, Russia, Japan, Australia, there's about 10 million people that lack access to clean water. Now you might think that's a lot, but when you compare it to, let's say, the continent of Africa, that number nearly jumps 35 times to 345 million people. Okay? So there's 345 million people that lack access to water in Africa. So what does it mean to lack access? Well, the World Health Organization, the WHO, defines about 25 to 50 liters of water as being the necessary amount for a person to survive on a daily basis. So by definition, somebody who's lacking access to water, anyone want to take a guess about how much water they get per day? Anyone want to guess? Just yell a number out. Help me out. Somebody from my class who's going to get a curve on an exam, yell something out. All right, great. Did you see that? How well did that work out? So it's actually about 5 liters of water, which if you think that's a lot, well, this is the next thing I want to talk about. How much water do you use every day? All right. So I went onto the United States Geological Service website, and they had this form you can fill out, and you can pick all the different things that you do during the day that involves water consumption. So here are some of the things I picked. All right, just to make mom happy, we're going to brush our teeth twice a day. That's pretty normal. We'll say we flush a toilet 3 times a day, and then I guess if you're flushing the toilet, you're washing your hands hopefully at least 3 times a day. And you're going to take 1 shower, 10 minutes. How many people take 10-minute showers? That's a joke, right? It's a lot longer than that, but that's what I chose, a conservative estimate. We'll assume you dishwash by hand, you do your own cooking, and also you have, drinks that you consume all day. Now, just picking the conservative amounts on this form, one American, on average, doing these things, consumes 170 liters of water per day. So that's a big difference. 5, 170. So how do you compare that number to the world consumption of water? Well, if this glass of water that's going to show up on this screen here represents the water consumed by one African family, so that would be 4 people. If that glass was the consumption of water from 4 people, these 35 glasses are how much one American consumes in a day. So we consume way more than a lot of people in the world. All right? I was talking to a buddy of mine the other day, and we're really into comedians. And we were talking about George Carlin. Does everyone know who George Carlin is? Even some of the younger folks, right? You may have heard a skit that he did about golf courses. He really hated golf courses. He was talking about low-income housing in cities, not having the land area available. He says, let's take all the golf courses, put them together, make low-income housing, right? He said if you took 2 Rhode Islands and a Delaware, you'd get all the land area that we use in America for golf courses. So I got to thinking, every time I've been to a golf course, now I have to admit I've tried golfing, but I can't get that stupid ball to go straight when I drive it, so I don't do it very often. But if you want to talk about golfing, there's about 18,500 golf courses in the US alone. Now the next two stats are pretty staggering. There's about 27 million US golfers, and just to irrigate the golf courses, they use 7.9 billion liters of water per day. 7.9 billion simply for 27 million US golfers. So you remember that stat, 345 million African people having the minimum amount of water per day? If you look at that 345 million number, multiply it by the UN minimum consumption rate, they only need 6.9 billion liters of water per day. So here in America, to service 27 million golfers, we're using almost 1 billion more liters of water just than we would need to give water to the people who need it in Africa. All right, so as Americans, we're kind of over-consuming water. All right? Now, what does that do on the world scale? Well, it kind of just puts us in a little bit of bad light. Now, Mark asked me not to make this completely depressing, right? So there are some things that we have available to go ahead and combat this problem. All right, I'm just going to talk about one specifically, and then the other panelists are going to talk a little bit more about some others. And one is water desalination. So this is a chart I found. It's pretty interesting. It shows a bunch of different countries in the world and how much water that they get from either, this would be wastewater or water directly from the ocean. So water from the ocean, you have to take away all the impurities, including the salt. So I'm just going to point out one country here, Saudi Arabia. If you were to extend this vertical access here, now these units are strange, so it's 5,000, but then each one of those represents 1,000 cubic meters of water. And we know that there's 1,000 liters in 1 cubic meter. So Saudi Arabia, if this is extended up to the 7,000 mark, Saudi Arabia in one day can desalinate enough water for the entire continent of Africa to give those people the water that they desperately need. All right? So the technology's there. Okay? Now you'll notice up on the podium here we have glasses with pitchers of water. In the back there's pitchers of water. Mark told me we didn't want to do bottled water this time, but I wanted to bring one as a prop. Because there's a lot of myths about desalination. A lot of people who talk bad about desalination say the technology isn't there. But if you actually looked at the label of a Dasani bottle, there's one really important thing. It's the process they use to take tap water in different regions and make it drinkable. They use this process called reverse osmosis. All right? Every new desalination plant uses this process that is over 70 years old. We have the technology to do this. This isn't something that's being experimented with. This is technology that we have right now. And all new desalination plants on Earth use 100% reverse osmosis. So the smallest plant that they've been building, and Israel's a big place where they build these, they make 45 million cubic meters of water per day. All right, if you translate 45 million cubic meters of water, essentially you're talking about 4 billion liters. All right, so it's just about enough to give water to people in Africa. Now, if we had these desalination plants in Africa, what do you think the big thing would be to try to get that water around to people in Africa? Does anyone know? What's a big problem in Africa with transportation? There's no infrastructure. I mean, there's really no highway systems. They're laughing up here because they were just in Uganda, and they're probably laughing because it's true. All right, so there's no way to get things around. So there has to be a lot of local solutions in these places. So I wanted to show you one such solution. Now, this isn't in Africa. This isn't in the desert somewhere. This is actually in California, because believe it or not, California has a big problem with fresh water. This is pretty cool. This is actually using solar energy. So everyone remembers their conic sections from pre-calculus, right? Everyone's good with that. So these solar arrays right here are in the shape of a parabola, and everyone knows a parabola has a focus. So it focuses all the sunlight on this pipe that is traveling down here. So essentially the solar energy heats up the water that's in the pipe. It creates a steam, which then pushes the steam and the water through the pipe, and it basically condenses, and then you're left with clean water. So this is one mobile plant that they have working in California that could possibly be used in Africa as a solution for a local site. All right. Before I finish up, I'm just going to say, you know, there's problems in Africa, there's problems in other places of the world, but there's also problems here. I don't know if you've if you guys read the news a lot, but there was a case in West Virginia. There was above ground storage facilities holding chemicals where people didn't even know how terrible these chemicals were, and they were leaking into that river in West Virginia. And all those people know, right now, I still don't think that they have a viable drinking source, so they have to truck in all of these trucks with gallons of water in there, and that's how they have to get their water. In North Carolina, there's these coal ash ponds. So essentially, a coal electric generation facility has all this byproduct, and they just dump it in these ponds. So what the companies are starting to do is take that water and pump it into streams that people are getting their drinking water from. So this is a problem. And then obviously, in Pennsylvania, we have this whole fracking issue. All right? Now, both sides of this fracking debate are so loud that we don't really know exactly what's going on. And my fear is that we're not going to know until there's an actual problem before it happens. Okay? So that was my introduction. Just wanted to kind of get you thinking about some things you may have not thought about before. So I guess I'm going to hand this back to Jack, and he's going to go ahead and put the panel up on stage, and hopefully you all have questions, and we can get started. Thank you.
Thank you, Professor Truncale. I would now ask the panelists to please go up to their seats and to begin the questioning period. I would also like to note on our distinguished panel tonight, there is a state senator, senior faculty members, and a student. If the panelists can introduce themselves briefly and I ask you to talk about your relationship with sustainability and how that affects your work and your life as well.
Well, I guess I'll start. I'm Dr. Grossman, and I am an assistant professor in exercise science. And my really role with sustainability, or how I have worked with this, has been I was fortunate enough to take a one-week sustainability conference that was offered to faculty members. And so I teach nutrition, particularly an introduction to nutrition. And so I thought, after having taken that one-week class, it was really a great opportunity for me to infuse the concept into my lectures and really to extend the work and the curriculum to look at organic foods, local farming, where does our food come from? And so I did that last year for the first time, and then we did an extension of the class and did a field trip to a local farm, which is in Luzerne County. It's called the Lands at Hillside Farms. And this farm is a 412-acre farm. That's a very old farm that was originally part of the Cunningham family. And Mr. Cunningham was a coal baron. He was very wealthy, and this farm really was just kind of dilapidated. And so a friend of mine who was a vet is very passionate about sustainability, and so he was able to raise enough money, and the farm was purchased. And so this farm now is an amazing work of real-life sustainability in terms of creating this understanding for everyone. Doug Ayers is his name, and he says, you know, this is a farm where it's your farm. Your kids need to realize that they can come here, they can adopt a cow, and they can work on the farm and really understand where our food is coming from. And so the Lands at Hillside Farm in the last 4 years has really worked very intimately with the local community to really have a level of impact in asking us, you know, where is our food coming from, the milk that we're drinking, the eggs that we're consuming. And so for me, it just became really a passion. And so I was fortunate enough to be a board member. So my contribution is a little bit different, I think, than most others on the panel. And so I'm just delighted to be here. So thank you. It's a little long-winded.
Good evening, everyone. I'm Jessica Nolan. I'm a professor in the psychology department, and I'm also the newly appointed director of the environmental studies concentration. So if you get really turned on by what's happening here tonight and you're not already an environmental science major, talk to me about the environmental studies concentration, and you can get a little piece of this in your time here at the University of Scranton. So you might be wondering what a psychologist has to do with environmental issues. I don't put people on couches and ask them about their feelings and their experiences with their mother. I'm a social psychologist, more specifically a conservation psychologist. So I'm interested in using the tools and methods of psychology to understand and solve environmental problems, which are really human-caused problems. So psychology is all about human behavior and how to change it. And if environmental problems are caused by humans, then psychology has something to say about how we can solve those problems. And so I have a long-standing interest in sustainability, and I'm also very pleased to be here tonight.
Thank you. I am Senator John Blake from the 22nd Senatorial District. I serve in the Pennsylvania General Assembly along with 49 other senators that represent about 255,000 people each throughout this Commonwealth that has 12.5 million people. And I guess I want first to say thank you to the university and Dr. Truncale for the invitation to be here. Delighted to be on the panel. How does sustainability affect me? Well, I preside over the decisions that you and your families and your communities depend on. In terms of water, in particular water quality, the regulatory framework around which we guarantee the lack of pollution, the fact that you have access to water, the fact that we have a PUC-regulated water supply and conveyancing industry throughout this Commonwealth, public and private companies and concerns that are basically involved in that. And you heard Dr. Truncale mention new industry, which is growing here in Pennsylvania, the natural gas industry and the fracking industry, which is, by the way, an enormous user of water. I have a few comments I'd like to make, some stats that'll tell you a little bit about Pennsylvania, and I'll share them with you tonight. But mostly I'm here as a public servant responsible to preside over decisions in the General Assembly that affect your lives. And I was glad to be here at the previous sustainability conference. I really appreciate the opportunity to be part of this dialogue and to hear what the students and faculty have to say, and I'm delighted to be here tonight. Thank you.
Thanks. I'm Dr. Ledford-Miller from the Department of World Languages and Cultures, and my field is language and literature, but my area of interest and expertise is primarily Latin America. I've also lived in Africa and have worked with students and additional faculty members to take study abroad groups to the Global South in Mexico with indigenous women and in Rwanda with Rwandan women and cooperatives. And all of the areas in the Global South are challenged by issues of water, and that's the access of water that Professor Johncale brought up, and also cleanliness of water, latrines, all of these issues which lead to disease or heavily impact women in particular because they are the water gatherers primarily. So that would be my interest, and for myself and my students and anyone I come in contact with to be a better local and global citizen on all issues of sustainability. Thank you.
Hi, I'm Caroline Earnest. I'm currently a sophomore environmental science major at the university. Sustainability affects my life because it is the career path that I've chosen. I would like to take my education further and do environmental engineering to help solve some of these problems, but my relationship with sustainability right now was with the solar panels that Professor Truncale designed. I took those down to Uganda and set them up over intercession.
Cool.
Hi, my name is Erica Lasek-Nesselquist. I'm a professor in the biology department, and I focus on molecular biology and evolution, particularly of microbes. And I'm interested in disease, evolution of disease, ecology and evolution of disease, and transmission of those diseases, and particularly how humans impact those processes.
Mark, do you want me to come? Okay. I just have Professor Truncale talked about a couple of solutions to the problem, and I have a couple of other things to share with you before we get into questions. How many of you have heard of the Millennium Development Goals? Not too many people. Okay. This was something put together through the United Nations. 198 countries, I believe it was, set 8 goals. And these goals are to be reached by 2015. They're falling short, but they've made a lot of progress. And the 8 goals have to do with poverty, education, equality, gender equality, these kinds of things. But as you can see from here, one of the goals relates to sanitation and water for all. So if you think about issues of poverty, health, education, health in particular, and even gender equality because women and children are the water carriers, water cuts across at least half of the 8 Millennium Development Goals.
UTEC, the University of Engineering and Technology, was about to open the application period for 2013, so they needed to call students' attention.
Okay, the next thing is an approach done in Peru. The particular city is Lima. Peru is a very dry country. The Atacama Desert is there. I don't think they've had rain there in 100 years, but even the city of Lima itself is extremely dry. It is so dry that they have ruins there made out of mud bricks that are hundreds of years old, and they're intact and they're in perfect condition because they've had so little moisture. So what do you do when you have impoverished peoples living in large areas that are very slum-like and in a very dry area? Here's one of the things that engineers did.
Lima and its surrounding villages are located in the coastal desert of Peru. In this place, there are many people suffering from the lack of potable water.
Acá en este pueblo de Pujama, todos, mayoría sacamos agua de pozo. Y no es agradable y es contaminado.
The presence of rain in this region is almost zero, but the atmospheric humidity is about 98%. Inspired by this, we worked as a team, UTEC and the agency, to build the first billboard that produces drinking water out of air. The billboard has a unique technology that captures the air humidity and turns it into drinking water.
Cada generador atrapa lo que es la humedad del ambiente. De ahí pasa un sistema de osmosis inversa. Cada tanque almacena el promedio de 20 litros. Las 5 máquinas van a hacer este proceso y se va a almacenar todo en un solo tanque.
The billboard has already produced thousands of liters of drinking water. That equals the water consumption of hundreds of families per month.
¿No? Que pongan en diferentes lugares, ¿no? Si es posible en cada anexo, en cada caserío, en cada pueblo, para que el agua sea generada por medio de los paneles. Un agua que realmente nos da vida, ¿no?
Yeah, it's really a wonderful project, and I don't know if it's been replicated elsewhere yet. And, wrong one. This is another adaptation. This is a company, LifeStraw, that if you buy a straw, you provide a straw for someone in another country, kind of like Tom's Shoes, but even better, I'd say, since you can make the shoes yourself in the country you're sending them to. But at any rate, they have different adaptations for community, but there's an individual straw, and you can put this straw in. A camper can use it, or someone with non-potable water can use this straw, and it lasts for a couple of years, and it's very inexpensive. So that's a small solution, but a ready solution. And then finally, and as you can see, it filters out even worms and so on. This is a pump that's being used in different African countries, because sometimes you have a well, but you can't get the water out of the well. A lot of times, developed countries like ours will go in with some heavy technology, and that does not work well for the local population. They don't have the trained people to run it. They don't have the tools to fix it. They don't have the parts to fix it. So very often what's needed is a more simple solution. But even the simple solution has to be thought through carefully, because in certain cultures, a woman should not be in a certain position, for example, in public. And so things have to be thought out in terms of what functions for the culture and conditions of that local population. And this is just a very simple and inexpensive pump. Thank you.
Thank you, Dr. Ledford-Miller. At this time, we will begin the question and answer section of the symposium. And I just want to ask a question for Caroline Earnest. You briefly described your trip to Africa. Can you explain to our audience a little bit the value of your trip and some of the details about setting up the solar panels and the energy power supply that was designed by Jim Lovin and Professor Truncale?
So this January, I was given the great opportunity to take Professor Truncale and Jim Lovin's solar panels to Uganda to set them up. Our plan was to set them up at 2 different schools. And speaking about water, one school that we set them up at, we sent down a pump, which was surprisingly small for the school to use to get their water, because before that, children were taking time out of their education to pump water out that wasn't necessarily clean. And things like that are a real problem in developing countries, where people not only don't have the resources, but they also lose the time that it takes to get those resources. But more about my trip in general and sustainability in Africa, being down there, you really see that nothing is wasted. It's even hard to find trash cans in some places because they just don't throw anything out. That being said, what trash there is, there's no infrastructure really to take care of it. And a lot of things end up discarded, or things get into the water system because there's no treatment for it. Things become polluted. In Uganda, which is where we went, only 12 million out of 34.5 million lack clean water, and only 18% of the country has proper sanitation of that water. So a lot of the water sources are dirty or not treated the way they should be. Being a tourist in that country, you're not allowed to drink the water for a lot of reasons, but even some of the people down there who, it shouldn't affect them the way it would affect us, they still can't because it would make them sick because of the diseases and because of the unclean nature of it. There's really like I said, there's no proper sanitation, and a lot of the toilets that they have down there are just pit latrines, so, bodily fluids go right back into the water system. When you get outside of the capital city, which is Kampala, things get really rural and things get a lot worse. When we started leaving the city, we stopped at a gas station, and our professor said, "Use the bathroom now, this is the nicest one you're gonna see for a while," and that was even a pit latrine. So it really gets worse the further you get out. They have problems sometimes teaching native peoples the proper way to use the toilets. We encountered the Pygmy people who lived in the rainforest up until 1993, but they were kicked out because of the lowland gorillas are silverback gorillas are endangered and they live in their habitat. So the government kicked them out, and they had a really hard time associating into the culture of the rest of the country, and they had a really hard time teaching them how to use even pit latrines, because they just went wherever they wanted to before, and that was their culture, and they didn't understand. So it took them a couple years to grasp these concepts. So these are problems that they seem like they might not be real or significant, but they really are. The solar panels that Professor Truncale designed would provide electricity to a school that had none, so they could now teach at night. They could offer night school for a lot of adults. Electricity is another resource that they don't really readily have access to, and the solar panels make a really great use of a resource that they have plenty of, which is sun. Setting them up down there it was a difficult experience. Being out in the field is really different than being here, where you have all the proper tools. You have to take in a lot. We had to take down a lot to be able to set them up, and it takes a lot to really set them up and get them going down there. But in the end, we were semi-successful. We got the solar panels up, but not in the exact way we wanted to, because we wanted to have them on the ground, but theft was a real problem, and because resources are tight down there and people will take anything they can and sell it for money. So we set them up as regular solar panels until they could get the proper funding to get fencing that they needed to protect the panels. That being said, they still made a really great use of the pump and of all the tools that we set down there, which are really going to help advance the school.
Thank you, Caroline. At this point, I would like to open it up to the audience for any questions for the panelists themselves. Does anyone have a question?
I have a question for the professor of physics. When water goes through different stages, when it freezes, when it turns into a liquid, when it turns into a vapor, there is energy released in calories. About the desalination plants, the reverse osmosis, is there any form of energy that the water either releases or absorbs when it gives up its salt?
Well, I actually don't know much about that actual process.
This is hard to hear, but I think she
I
says.
know it actually doesn't take a lot of energy to desalinate the water. It's only about 3 kilowatt hours per 1,000 liters of water. So if you wanted to actually desalinate enough water for the entire continent of Africa, black water, it only costs about $20 million a day, which is actually not too much. If you look at total African GDP, it'd only be about 0.5% of that total. So if you want to know about entropy and things like that, that's not Japan.
Let me just ask a question while I've got the microphone. Nick and Caroline, right? Have you thought about solar stills in Africa? Are they using those at all over there? Solar stills, solar cookers, that sort of thing?
They do use solar cookers.
But the solar stills have been used quite a bit in developing countries, and again, the reverse osmosis takes a significant amount of energy to create the pressure.
Does anyone else have a question to ask? Yep.
I don't know who could answer this, but how do you see the university being sustainable in the present day?
How do you see the university being sustainable in the present day?
Yeah, like what actions do we take to be sustainable?
Well, I think there's a lot of attempt at sustainability. I know that our new science building is a LEEDs building, and that is a sustainable criteria. I also know that we have a lot of recycling containers on campus. I see the maintenance staff picking up the cardboard and the paper. But I think there's a lot of missed opportunity for recycling because, first of all, we don't need to use water bottles, and I was very glad we didn't have them this year, Mark, because I did notice them in the video from last year. I think it's something like 2 million water bottles a day are not recycled, and I know that there are hundreds of them not recycled on this campus because every day in my classroom in Highland, I go to the trash can and take out the plastic bottles, the glass bottles, and the cans, and walk them 20 feet to the recycling container. So there are a lot of missed opportunities, but there is certainly a lot of intentionality about it.
I'd just like to point out that materials can only be recycled so much. So while it's great that you recycle, even though a lot of recycled materials will eventually wind up in trash. So while recycling might be one strategy, there's really got to be a cut down on, in general, just plastics and things that are one per use. Go towards things like mugs or water bottles that you can reuse a lot of times. So I think on the Cornell campus, they had a statistic where for the same amount of volume of water, water bottles, it cost them something like $640,000, but for the same amount of water that they could get from tap, it costs something like $1,000. So there's also an economic component to sustainability.
Yeah, and your tap water is not necessarily worse. What I want to say is the reverse, actually. Your bottled water is not necessarily better than your tap water. There have been a lot of studies done on that. Another addition is that if you are going to use things and you do recycle them, then consider buying products that are made with those recycled products. And there are a number of brands available of a lot of different things that use recycled plastics, for example.
And I know Mark Murphy, our Director of Sustainability, would want me to say that the most important thing we're doing for sustainability on our campus is we're educating you about sustainability, so that when you leave here, there will be ripple effects to everything that we do as a faculty and as a university on our campus. So Dr. Grossman's course, where she infused sustainability into a nutrition course. A nutrition course doesn't have to include anything about sustainability, but thanks to Dr. Can and Dr. Sharon Moore in philosophy, for the last 10 or so years, faculty across our campus have incorporated sustainability so that you hear about it sort of everywhere you go, right? There's always a faculty member talking about sustainability in the context of their discipline within your major. Hopefully you've come across that. And so when you go out, the things you do as a result of the knowledge you've gained related to sustainability and all that needs to be done, I think Mark would want me to say that that's the most important contribution. He could also say a lot as our Director of Sustainability about lots and lots of things we do on our campus. And I know he also just got appointed to that office. And we're going to make a really good website where we advertise all of the cool stuff we do, because we do a lot more than we advertise. We haven't been good about sort of bragging on all that we do, but we do a lot.
So I actually have a question for Mark Murphy, if you could answer. So one of my huge issues is so I'm new, so I don't know if this is in place, but the lack of composting on campus. So I know that, just as a campus, any university is throwing away a huge amount of food. So what could be done minimizing that waste?
It just happens that I'm a list maker. I make lists so that I don't forget the things that I'd like to get done. And on my list, one of them is what I'm calling the Royal Community Garden, which I'm hoping to see up on North Irving Avenue probably by next fall or springtime. And in there, what I would like to have is a not a test location, but a location where we'll do composting, but not composting so that it's in mass, so that it's something that we're intending on using throughout the entire campus, but something that the people that would be having these community garden plots would be using that compost. But I want to get the biology department involved, because I want an academic feature to attach to that Royal Community Garden, because I need that academic support. Because when we do the composting, I don't want it to just be a bunch of piles that people put together. I want the people to be educated so that they're aware of the proper way to do it, the proper mixtures that need to be put into the composting to make sure that the pile doesn't smell, to make sure that it does decay the proper way, so that they're using the right materials. And that's what I'm looking for as part of the Royal Community Garden. But I'm also looking at, as far as our Airmark services, they have this system where they take pre-consumer waste products from food. So it'll be the potato peelings, the carrot peelings, all that sort of stuff. They actually weigh that material when they process it, so that they have the efficiencies of how well they're doing it, so that they know whether if it's Jack peeling versus Mark peeling, is he wasting half the bag of potatoes and I'm not. They have statistics on this. They keep it every single day. So the neat thing is I know how much pre-consumer waste they have, and it just happens to be that it wasn't enough for this one technique that I was looking into, which was a digester sort of churning device, which uses about 300 gallons of water a day. But it just happens that on our campus we don't have enough organic waste to use in that device. And I also didn't like that I was taking what I consider valuable material, that organic material, to be compost, to be able to use to go back, say, into a farm or into planting beds. I didn't want to see, because this system used to take it and it would put it down the drain as gray water. So that's a system that's being promoted out there. But what I'm looking for is, and I've spoke to Waste Management today when they were at our Earth Day fair, is they are slowly getting more areas where they are doing organic recycling. So they're collecting the organic materials, and I was willing to even go through the financial analysis to decide, should we take it to their plant down in Delaware where they do organic recycling already? And now I'm told there's a plant that's even getting closer to us. But personally, I don't know if that's the right solution. I might prefer taking our organic waste up to a property that we own nearby and do it in a large-scale area where it's also, again, make it an educational feature, make it something that we become a leader in that, so we can teach the community and use it as a resource and show other communities how to use it, because everybody's paying about $200 a ton to get rid of their waste to a landfill. So we want to stop the materials from going to the landfill. Like I said, I look at this as being very valuable material, so it's on my list, and we're working on these projects. And like I said, I hope to get some more assistance from people on the academic side to work these projects through.
I just want to make a quick comment from the public sector, because we have the ability to incent some of the behavior. Duryea, DuPont, local Pittston area communities actually got a grant from the state in order to create a community composting. And the other thing I would mention, and the issue of nutrition was brought up here. The Abington Regional Park, not far from here, a couple miles up the Morgan Highway, also has a regional park where citizens basically lease a portion of the large garden. The communities, there are 4 or 5 communities that pitch in to allow for composting of that land, and they basically create the opportunity for vegetable gardening in conjunction with the municipality. And the last thing has to do with nutrition, has to do with the access, the poor access to nutrition in poor neighborhoods and in urban centers. And if we could figure out a way to do a little bit better on the waste side of the equation, we probably can do a better job of creating nutrition in some of our inner cities.
I have a couple of questions for the senator, if you don't mind. You mentioned fracking earlier about using a whole lot of water. So I have a two-part question. One is, I think that we tend to think of water as an endless resource, and so what is the impact on our water supply that industry is having? And then secondly, on the quality of our water, because I think it was last year sometime that the water in Dimmock actually could be lit with a match. I think it was Dimmock. So they're kind of related questions.
So let me just say a few things, much in contrast to what you just saw from Dr. Truncale about access to water. I'm going to talk a little bit about closer to home here in Pennsylvania, and then I'll answer the question. Pennsylvania, our state, counts 86,000 miles of rivers and streams, 4,000 lakes and reservoirs and ponds, 23 square miles of estuary, 400,000 acres of wetlands, 500 acres of tidal wetlands. Closer to home, right here in the Pocono Northeast, the counties of Pike, Monroe, Lackawanna, Luzerne, Wayne, Carbon, they only constitute 8% of the entire state, but it's home to 20% of wetlands, 4,700 miles of streams, 7,400 square miles of lakes and ponds. I say this because Pennsylvania is a water-rich state. So the pressures on that supply of water are many. Most of them are PUC-regulated industry concerns, business concerns that deal with water supply, and we are very fortunate, thank goodness, to be an industrialized society that has built water lines that convey water. There was some years ago when that water was contaminated, and you get additional regulatory controls on the people who are responsible for providing safe water supply, and that regulatory control continues. The Lackawanna River, which flows the floor of this valley, was once an open sewer. It was basically an industrial outflow. It was where everything dumped into. So regulatory control, the Clean Water Act at the federal level, other issues basically said, hey, you can't do that. You can't dump industrial waste and raw sewage into waterways. And so water treatment plants were built, sewage treatment plants, wastewater treatment plants, as we call them. Some of those, many of those subsidized by taxpayers, mostly subsidized by taxpayers, either through federal, state money or at the local level, by the fees that people pay for using that wastewater treatment. The natural gas industry, getting to the question, is an enormous user of water. They are using tens of thousands of gallons of water per day. They use it in a variety of ways. They use it to lubricate the process of drilling itself, but more importantly, after they've broken a mile down, broken the rock that the gas is trapped in, they use water and some solids to keep the gas suspended, if you will, in the broken rock, and that's why they're such an enormous user of water. The larger business concerns, the big companies learned early on that they were going to have a problem in the draw off of water from our waterways, and you need permits. The Susquehanna River Basin Commission basically regulates the amount of water that's withdrawn from our waterways. If you go to the SRBC website, you can get a little bit of a glimpse on what they do in terms of regulating the Susquehanna River watershed and the draw off of water. The Delaware River Basin Commission would have jurisdiction over their watershed. The fact of the matter is, because we are a water-rich state, a lot of water can get drawn off by industrial and commercial users, and it is. The key to the public suppliers of water and the issues associated with the supply are that there's a regulatory priority to guarantee that there is sufficient water to serve the public interest, meaning citizens. and that takes somewhat of a secondary condition to a commercial or industrial use, unless it was going to threaten public safety, such as the water that's needed to cool a nuclear power plant, for instance. The issue about the industry is this. There are good players and there are not so good players. I think that the industry grew up quick in Pennsylvania without a real good regulatory framework. I have some issues that have come up, as was mentioned, relative to the migration of gas into water supplies, and these issues continue to be of concern. Also of concern is the transportation of water used at these sites. The dumping of those waters, a truck comes off the road, it dumps into a waterway, now compromises the water quality of that watershed or that tributary. So those are issues that continue to be of regulatory concern. I would tell you that DEP, if we were better resourced, we can better regulate. We don't tax this industry enough. If we did tax it a little bit more, we'd have more resources to regulate it. I do think that we have done a better job in terms of pipeline safety, some of the other issues that are mandated by the federal level to try to make sure that the industry is operating in good practices. But a lot, and the thing that concerns me most are those things upon which we rely upon the industry itself to self-report. I don't think anybody should be comfortable with that. And that's a function of resources at the state level. Recently, I'm going to give you two other things to think about regarding this industry. Just this past month in Harrisburg, there was a bill called Senate Bill 411 that said, well, why don't we use the acid mine water from the previous industry that compromised some of the environment here in Pennsylvania and allow this new energy industry to use it, so that way they won't have to use the good water, the high quality water. They can use this old water. Well, science weighed in on this. Citizens weighed in on this. The environmental lobby laid in on this. And that bill was tabled about a month ago in the Senate because of the unknowns and the dissatisfaction that we have enough science to make a decision about whether or not that's a good idea. The other thing is there has been a bill put up in the Senate to have a moratorium on drilling, on fracking itself, until such time that an environmental analysis could be done regarding its impacts. There's not bipartisan, widespread support for that moratorium. There simply isn't. But that's why people like you should keep people like me accountable. And that's why I show up at sustainability forums. The only other point I want to make is, and this is really something I'm just going to detour to, I want you to bear with me about what we in northeastern Pennsylvania experienced in a previous industrial era and what we ought to be concerned about relative to what Dr. Truncale said earlier, that we may not know until sometime in the future what it means to us in terms of this industrial situation and what impacts it might have on water quality. There is a borehole in Old Forge, which is might be 6 or 7 or 8 miles southeast of here, or southwest of here. It was drilled in 1962. The reason it was drilled in 1962 is because a whole pile of water built up in mine pools in this region from the previous mining operation. When the mining operation stopped, they were pumping all that water out to mine the coal, but once they stopped pumping all that water out because they were no longer mining coal, guess what? All the water built up in mine pools in all the caverns underneath the Lackawanna Valley. Well, the pressure started to build up, and this became a real public safety issue, so they drilled a borehole in Old Forge to release some of the underground water so that it can flow. And that was an okay public safety decision to be made in 1962, but the Old Forge borehole currently discharges an average of 60 million gallons per day, 94 cubic feet of water per second, and it has an iron loading, Fe, iron loading, of 7,700 pounds per day into the Lackawanna River, which flows into the Susquehanna River, which flows into the Chesapeake Bay. It is the largest single-point polluter of the Chesapeake Bay watershed. It's a function of underground water from early mining days being discharged into the waterways today. There's one not far from Old Forge that's the Duryea borehole, which discharges 14.5 million gallons per day, 22 cubic feet per second, and another 2,300 pounds of iron per day into the river. I say this to you because if we are into sustainability, and if we are interested in conservation, and if we're interested in environmental protection, maybe we should be careful about what we're doing. And maybe we should be mindful of the regulatory issues that prevail upon decision makers at the federal and the state and the local level about industrial operations. We are funding an operation that's basically informed by science and a public-private partnership that might find a way to use that iron, take it out of the river. It's going to take years to do, and there's going to have to be prototype and an analysis done, but there might be a way for us to finally use that iron in some commercial way and to have it removed from the river. Upstream from that borehole is a AAA trout stream. People come from all over the state, all over the northeast part of the country to fish for trout in the Lackawanna River. Below it, it can't sustain life. So, something to think about.
Just as a follow-up, since Senator Blake asked us to keep him accountable, I have several students tabling outside with information, and I think 3 of them are related to water quality, and one of them does have a petition that you can sign related to fracking and increasing regulations associated with fracking, and also protecting our state forest, the Loyalsock forest in particular, which is a pristine, untouched area that has not yet been subjected to mining and drilling, and so essentially to ask our lawmakers to keep it that way. So for anyone who feels, like you want to take action, there are opportunities outside those doors before you head home.
Thank you, Senator Blake and Dr. Nolan. Is there any more questions from the audience?
Yes, thank you for that. And Senator Blake, thank you. SB 411 is certainly a concern of mine, and I'm glad to hear that it's been tabled. And thank you for updating us. I would like to comment, as Dr. Grossman, about the hillside farms. I think that's a great opportunity for people to come and see where our food comes from. But unfortunately, I think a lot of our food is coming from factory farms and much bigger operations than that. So we really don't get a good look at that's an idealized, probably, where we should be going back to in that sense. But I think, unfortunately, much of our food does not come from that kind of a environment.
You're correct. On average, the food that you consume, when you look at food that's on your plate, it travels 1,500 miles to get to your plate. And so most people, I don't think, realize when you go into a grocery store and you look if you look to buy grapes in January are not coming from California. They're being, they're traveling from Peru or from Chile. And so we really, young children in particular, we need to be asking questions. Where is our food coming from? If we can buy locally, we can decrease our carbon footprint on this earth. And so that footprint, the definition that I have for that footprint is the amount of land required per year to provide the nutritional resources for one person. And so local farming, though it might sound like it's a buzzword these days, is really an important message for us to really understand in terms of when we buy food locally, it costs far less, it tastes better. And there are a lot of generous opportunities between Luzerne and Lackawanna counties. There's one in particular, it's called Fertile Grounds. And so a CSA is a community-supported agriculture. And so typically these are farms that are manned typically by volunteers, and you can choose to buy X number of crops throughout the year. Some people might say it's very expensive, but if 3 or 4 families go in on this, every week you have an amount of fresh vegetables that arrives at your doorstep, or you can go and pick it up. And so typically you have fresh vegetables for about 6 months out of the year. Many people don't know about those CSAs. There are several throughout this county, and so I think it's an important question. Yeah, the Lands at Hillside Farms is ideal. It is not the norm. It clearly is a start. I will tell you just one personal note. I have 3 children, and so we've started buying our milk for years now, for about the past 4 years. And so we have this routine. Every Sunday we go up and buy our milk. And so we have run out of milk, and my husband will go to Turkey Hill and get half a gallon of milk. And it is amazing to me. My children know that it's different milk. Now, when you have a 3-year-old who can say the milk tastes different, and the first time I thought it was like just coincidence. Well, then we did this little experiment, and it tastes different. So with that said, ask those questions of where food comes from. And fast food is probably the most expensive food that we consume. because of really, if we really looked at the cost of fast food in terms of all the processing that goes into that food, that truly is unsustainable in our country and really throughout the world. That's a whole other topic.
Factory farming also has a tremendous impact in terms of water, particularly cattle raising. It uses far more water than non-factory farming.
Thank you.
Question back there, Jeff.
Oh, question back here? Okay.
This question is really for anyone, but we've talked a lot about the importance of clean water, but if someone could just maybe elaborate on the consequences of dirty water, so how diseases are transmitted or the public health implications of dirty water. I know diarrhea kills more children than malaria and HIV combined, so whether you're a resident in Scranton or a visitor to a foreign nation, a developing country, or even a researcher doing work in this area, just the true danger of dirty water, if someone could just elaborate on that.
Excuse me. Okay. Thanks, Brandon, for your question. Yeah, so it's not only just a huge burden on quality of life, it's a huge burden economically. So as you mentioned, something like 200 million people are affected by Giardia alone, which is a parasite that causes diarrhea. And so for us, this might be a mild agitation in our day, but in a developing nation, if you're a child, this could mean life or death if you have one of these diseases. So the impact is huge in terms of disease transmission, right? So water is one of the main ways that we can transmit diseases, and this isn't just a human problem. So if you consider all the agricultural runoff, for example, from these very large farms, that's all essentially going into the oceans, and we can find anthropogenic effects on marine life in the oceans. So they have cases of cryptosporidium, another parasite, Giardia, toxoplasmosis. They're affected by antibiotics. They're affected by birth control that gets out into that's not treated by the sewer systems. So, so the effects are huge, yeah.
And of course, any transmittable diseases like cholera, for example.
Right, so cholera would be another disease transmitted through the water.
Also, from what I've seen in Africa, a lot of the rivers and places that they would get water from are kind of dirty, stagnant water, and stagnant water draws mosquitoes. Mosquitoes carry malaria, which is a parasite. So a lot of children, young children who are supposed to go get the water, it puts them at a higher risk for malaria.
You guys, one more question.
So I have a question for just like the amount of water on like Earth, and this kind of would be more aimed towards Senator Blake. So about 97.5% of the water on this Earth is salt water, and 2.5 is fresh water. And then broken down into that 2.5, if we just kind of like estimate, about 3/4 of that is from glaciers, about 1/4 is from groundwater, and about 0.014% is actually accessible us to drink. So since we're able to drill for like gas miles down and use water to actually aid in that process, do we have technology that would be able to drill maybe like into groundwater and able to like go through the purification process for us to drink? And if we have had technology to do that, why haven't we started doing that? Like what would be the consequences of that?
So I think economics really drives what business decisions we'll make and what technology could be brought to bear. The issue of even fracking is a relatively recent phenomenon because they couldn't drill that deep economically. So that's a factor that drives, I think, innovation is basic economics and the ability to afford something. The issue of whether or not you're saying whether or not, I mean, we've been depending on well water in rural Pennsylvania as a means to sustain, for a long, long time. The issue, of course, that we brought up here today is the protection of the quality of that water. The wastewater treatment issues that are being done are also a function of innovation. We used to do the plants, as you've already heard other panelists mention, that are just treating the water for impurities and allowing them to be discharged into our waterways and at a standard that the government says is acceptable. Total dissolved solids, we call it. But that's not the only way to do it. You can spray irrigate, and you can return water to the water table in ways that natural processes could sustain and basically allow us to do different things that are more effective. But the answer to your question is really a function of economics. At the end of the day, business will seek profit, and if they can innovate and create a technology that will allow them to do something they can't do today and they can profit on tomorrow, they'll do it. Mm-hmm.
At this time, we are reaching the conclusion of the symposium. I would like to thank the panel members for participating. Thank you to Dr. Harrington, Senator Blake, Dr. Lasek-Nesselquist, Ms. Caroline Earnest, Professor Truncale, Dr. Grossman, Dr. Ledford-Miller, Dr. Nolan. I'd also like to thank the Naples Center Maintenance, and a special thank you to Linda Walsh from the Provost Office for coordinating all the details, work orders, and communications.
Don't forget to look at the clean water back there on your way out.
I got it. Elise, where's my stirring assistant? Here comes Elise, and she has and it has been sitting for over 21 minutes after all the sediment and contaminants in it have flocked together. Hate to say it doesn't look very pleasant what's floating in it, but you can see, I'll put it up here on the table. The final step in this process is just to put it, typically what they put it through is just a piece of paper towel to filter out the solids that are in it. And then they tell you instruction-wise is you wait 20 minutes, and after that all the bacteria and viruses in it will be killed, and it is clear drinking water. And like I said, it's a wonderful program that the Procter & Gamble has, a nonprofit part of their business, where millions of these packets are distributed throughout the world to try to help prevent things like young children having diarrhea and getting dehydrated and then dying from malnutrition because of a thing is what we take for granted. And I hate to, after this evening, to say, oh, a simple thing like fresh water. It's not a simple thing. It's just something that we take for granted. So thank you, everybody, for coming, and thank you for the panel. Very good discussion this evening.
Who's drinking the water?
Hey, Mark, I think you should drink that water now. Let's go.
We're gonna hang around. It's a pleasure.
Oh, right. Thanks for your answers.
It's a pleasure.
Yeah, thanks so much for being here.